Okay, hey, we are going to look at problem 2.114. It's the last problem. It's this problem with the horizontal circular plate. So you have this horizontal circular plate weighing in at 60 pounds, and it's suspended from 3 wires that are attached to the support that all form 30-degree angles from the vertical, and then they form different angles in the horizontal plane. And we're supposed to determine the tension in each wire. Okay, so one of the big reasons I wanted to look at this was just to talk about this horizontal, vertical, given the angles. So what does this mean? I guess draw on here. On this angle right here from vertical is 30 degrees, okay? So what we need to do at some point in time, we know how we're going to do this. It's going to end up with the basic thing that we're going to use a lot. Sum of the forces in x equals 0, sum of the forces in y equals 0, and sum of the forces in z equals 0. Okay, so let's look at this. What is this going to look like? Well, if we take this object, it's 60 pounds, so there's 60 pounds going up. So what does that tell us? So let's look at the y component of each of these, okay? So from D to A, or A to D, right? What do we have? Well, the y component in the y direction is just going to be the t, oh, sorry, it moved on me, kind of messed me up, t AD times what? Well, in this case, it's going to be times cosine of 30, right? Because we have, I'm going to try to draw this over here, you have this force coming down here from D to A, right? And we're looking for this component of it. So this is AD in the Y. And what is this right here? Well, this is AD in the horizontal plane. We'll talk about that in a second. Although you can't read my writing, sorry about that. Okay, so this angle is given as 30 degrees. So therefore, ADY is simply AD times cosine of 30, right? So we got that, and that's true for all of them. Since it's 30 degrees, they're all equal. So D to C in the Y is going to be T CD cosine of 30, and the last one, D to B in the Y, is going to be TBD cosine of 30. Okay, so good. We have so if we take our sum of our forces, we'll take this equation, we'll write it down. Sum of our forces in y equals 0 is going to be what? Well, you're going to have the ups equal the downs, right? So if you consider at point D, say, so at point D, you have 60 pounds going up, and then you have these forces coming off here in the various directions. And the y component of all those are what we just figured out right here, right? So you have TAD. I'm going to pull the cosine 30 out of all these things because it's the same. Plus TCD plus TBD. All this times cosine of 30 is equal to 60 pounds. So that is our first equation, sum of the forces in y. So that one's pretty straightforward. Okay. So that's our first equation. Now we need to figure out the other equations, sum of forces in x and z. And this is where things get a little more complicated. So let's come back to here. We have this one right here. So I said this is our vector. This is this vector right here. All right, let's go over here. You have this vector here. Okay, so that has a component that's in the y direction, and it has a component that's in this direction right here. And that direction is in the horizontal plane in the xz plane. Okay, and so what is the magnitude of that? Well, as we saw from this thing right here, this is AD times sine of 30. I wrote 35 up here. That's supposed to be 0. So the vertical is AD cosine 30, and the horizontal is AD sine 30. But that horizontal is, as you can see in this picture over here, it's a portion over here that's not an x or a y. So now let's look at this. Let's draw this vector. Let's draw this axis like this. You have the x-axis and the z-axis. And this vector came off here, I'm trying to match what they did here, at 50 degrees. So this is we called it the AD in the horizontal. And we figured out what that is. It's right here. It's AD sine 30. Okay. So what is the x component of it and what is the y component of it? Or sorry, that's the z component of it. Well, the x component, or sorry, the x is going to be AD horizontal, right? Times, it's the opposite, it's over that angle 50 degrees, so times sine of 50, and it's in the opposite direction of x, and so it's minus 80 h sine 50. But what is that? We know what this is. It's right here. We just wrote it up here. So this is the x component. So I'm going to put this AD in the x is minus AD sine 30 times sine 50. And what is the z component? AD in the z is going to be AD, the horizontal portion of it, this portion again, right, times cosine of 50. But again, we know what this is, and so that is equal to AD sine 30, because that's what this portion is right here, times cosine of 50. So this is the AD in the z direction. And so you can go through and you can do that with all of these, right? So let's look at AB. So if you look at the AB, again, I'm going to draw this axis right here. This is the x-axis. This is the z-axis. The AB vector, ends up coming down, it looks like about there, where this angle is, whoa, hey, none of that now. That angle, please, is 40, right? Again, we'll call this BD horizontal. So therefore, BDY is, we figure that out up, right there, right? BD in the x direction is going to be BD horizontal, BD, the horizontal portion of it, which is this value here, and since this is, it's going to be times cosine of 40. Well, what is the horizontal portion of this? It's again, it is BD times sine of 30, sine 30, all that times cosine 40. And then BD in the z direction is going to be similar. It's going to be d horizontal times sine 40, right? But the horizontal portion is, again, BD sine 30 times sine 40. So the point is, you have to look at these things as kind of the vertical component of it and the horizontal component of it. The horizontal component has x and z portions of it. It turns out that the way it's written, the vertical just has the y, so it's interchangeable. And so this is the z, this is the x, we have this x and z, and then the last one we have to do is the CD, so I'm going to scroll that up here. Again, I'm going to draw this axis like this. We have the x, z axis, right? And this CD is coming in that direction. That's not very to scale. I'm going to erase that even because it's really misses the scale. Okay, let's go back to the pen. It's coming way up here because this is at 60 degrees. And so therefore, CD in the x is going to be CD, the horizontal portion of it, times cosine of 60. So again, the horizontal portion of that is CD times sine 30 sine 60. And CD in the z is going to be, this is the positive z direction, so it's going to go in the negative direction, right? So it's going to be minus CD horizontal times sine of 60. So that is minus CD sine 30 sine 60. So now we have CD in the x, sorry, CD x, CD z, BD x, BDZ, and AD x, and ADZ. So we already did all the y's, which we figured out up here, and this is this equation. This is our first equation right here, right? So now we need two other equations. I'm going to scroll down a little bit. We have our sum of the forces in x equals 0. Well, there's no external forces, so the only thing that's going to be is the three forces of the as written in the three forces of the x, the BD, the CD, and the AD in the x direction. So let's write those down. We have BD sine 30 cosine 40 plus the CD sine 30 sine 60 and plus the AD sine 30 sine 50. Now you can see then this is all equal to 0. You can see you can get rid of the sines 30 out of all of them, right? But so that's one of your equations, and then the other equation is going to be sum of the forces in the z is equal to 0. So what do we have? We have BD sine 30 sine 40 plus or in this case, sorry, it's not going to be plus, it's going to be minus, because it's a minus CD sine 30 sine 60, and then, oh, I'm sorry, on the one above it, I forgot a negative sign here. This is negative because of this right here that I didn't write. And this is going to be plus AD sine 30 cosine 50 is equal to 0. Again, get rid of all the sine 30s. And then, well, I'm going to rewrite the sum of the forces in y equals 0 is, we have it right here, we have it here, and it's the TAD, so it's AD plus BD plus CD, I'm manipulating a little bit, is equal to 30 or 60 over cosine of, what was this, 30. So here are our three equations. Our unknowns are AD, BD, and CD. Three equations, three unknowns. So at this point, I'm not going to walk through actually how to solve the unknowns in the equations, but I'll show you the answers. It turns out that AD is equal to 29.5 pounds. BD is equal to 10.25 pounds. And CD is equal to 29.5 pounds. So that is how you do it. So that's your final answer. So again, to me, the takeaway of this and why I wanted to bring this up on video is to go through and just show you that when you have these things given as angles, the way they're given this angle, that's the 30 degrees. This is the horizontal component. You have to figure out the vertical and horizontal. So your approaches to these are going to be to figure out the vertical component and the horizontal component, and then look at this thing and say, hey, this horizontal component still has two additional components in it. It has the x component and it has the z component of it. And once you do that, it's actually not a bad problem. It's a pretty straightforward problem, but you have to spend a minute to go through and figure that out first. That's it.